There are a few different ways that you could think about this for correlation and causation. The one example that I always think of is the one that's pictured on the board, except I would slightly change one of these, but I'll let you know in a second. All right, so remember we talked about how when it's really hot outside, no headphones, guys. When it's really hot outside, ice cream sales tend to increase, right? Now, there's a relationship between that, there's a correlation between that. But are there other reasons that someone may want ice cream other than it being hot outside? Yes, like maybe because it tastes good, maybe because they're just in the mood for it. Like, do they sell ice cream in the winter too? So I wouldn't say that the sun causes you to buy ice cream. If there's other causes, that is not causation. So I would change this on your paper to correlation. All right, there's a correlation. There's probably even a strong correlation between the two. But I wouldn't say that the sun causes you to have ice cream. Some people wouldn't buy ice cream just because it's hot outside. On the other hand, though, when it's hot outside and you're standing out there, you do sometimes get a sunburn. Now, are there other causes for a sunburn other than the sun? No, right? We know for sure that only the sun causes sunburn. So in that case, it is causation. So if there's other reasons that could explain why this is happening, it's not causation. So this one, it is causation because only the sun causes sunburn. Make sense? Now, if I were to plot the data of ice cream sales versus sunburns, I might see a strong positive correlation because they both increase when the temperature outside increases. Now, does that mean that ice creams cause sunburns? Right? No, ice creams don't cause sunburns. Does that mean that sunburns make you want to have ice cream? Not necessarily. All right, so that's why this one is just a correlation. So just because there's a correlation does not mean causation. Questions? So to fill in these blanks, so it's either going to be causation or correlation. So it means that a change in one variable results directly from changing the other variable. So what do you think that is? Correlation or causation? It would be causation. Good. Changing one variable, directly changing the other variable, or resulting directly from changing the other variable is causation. In cases of causation, it's reasonable to expect correlation, like the sun giving you a sunburn, or the fridge making your water cold. All right, there's a correlation between that. But the opposite is not true. Observing a correlation between variables does not necessarily mean causation. It does not necessarily mean that one directly changed the other. You need more data to represent that. Questions? Go ahead. So then down here is a table that summarizes it from like your online textbook. So take a look at that. All right, correlation is represented by the R value. So like -1 to +1. Correlation can be positive or negative. Causation is like this definitely causes the other. Like there's nothing else it can be. So it should not be assumed even when there is a strong correlation. All right, that's the whole summary of this lesson. If I had to summarize it in one sentence, it would be this one. All right, so we're gonna look at a few different scenarios and fill in the blanks, make sure we really understand what's going on. So we have example A. The manager of an ice cream shop studies its monthly sales figures and notices a positive correlation between the average air temperature and how much ice cream they sell on any given day. What are the two variables, or what's one of them? The sun, or like the air temperature. I'll use the words in the problem. Air temperature, and what else? Ice cream shop sales. Good. So identifying the variables. What are the two things being compared? So we're comparing ice cream sales to the temperature outside. Since they're noticing a positive correlation, what would that graph look like? Going up, so as one increases, so does the other. So maybe the graph looks something like that. Now for this part, it's likely that blank causes an increase in blank. So it's going to be one of these two variables for each blank. So is it likely that ice cream sales cause an increase in air temperature, or the opposite? Good. So it's likely that air temperature cause an increase in ice cream sales. It's doubtful that blank cause an increase in blank. Good. So it's doubtful that ice cream sales cause an increase in air temperature. All right. Question so far? Even though there is a strong positive blank between temperature and ice cream, this does not imply blank. But what goes in this first blank? Correlation or causation? Correlation. All right, we describe correlations as strong positive, weak positive, things like that. So that would make sense that it would be correlation. What does the second blank have? Correlation or causation? All right, causation. So just because there's a strong positive correlation, this does not imply causation. Because there are other reasons that someone may buy ice cream. Questions about that? All right, one more together. So on the back side. And I'm going to have you not shout out the answers until I ask for them. So for part B, we have a group of biologists is studying the population of wolves and the population of deer in a particular region. What are the two variables, or what's one of them? What are the things being compared? Deer. So deer population, and what would the other one be? Wolf population. All right, if you switch them, put them in different blanks, that's fine. Those are my two variables. Deer population versus wolf population. The biologists compared the populations each month for 2 years. After analyzing the data, the biologists found that as the population of wolves increases, the population of deer decreases. What would that graph look like? When wolves increases, deer decreases. So you can show me with your hands, you can describe it to me. How would this look? So it would have like a negative slope, right? So something like that is what we're talking about. It's likely that an increase in blank causes a decrease in blank. So of our two variables, what one goes in here? All right, wolf in the first one, I'll abbreviate it. And what in the second one? All right, good, that makes sense. Why does that make sense? Like, what do you think is going on? Good, you're right, but be more specific. Why would the deer decrease? Because the wolves are eating the deer. All right, so that makes the most sense that when wolves increase, so they need more food, the deer will decrease. So it's doubtful that a decrease in blank causes an increase in blank. So what's the first blank? Good. It is doubtful that a decrease in deer population causes an increase in wolf population. I don't see why having less deer would create more wolves. So we filled that in correctly. So even though there's a strong positive or negative correlation, all right, what do we think? Someone else weigh in. So since our graph is going downwards, there is a strong negative correlation. All right, because when one increases, the other decreases. So even though there's a strong negative correlation between the two variables, this does not imply what? Good. All right, starting to see the pattern. Just because there's correlation, that does not mean it's the only cause. More research would have to be done to prove that. Questions? All right, don't pack up yet. Try the one that's underneath it, and we'll go over it in 2 minutes. All right, so try filling that one in on your own. And then still don't pack up because we need to go over it to see if you're right. All right, so educational researchers are investigating the relationship between number of musical instruments a student plays and a student's grade in math. And there is a lot of studies on that, by the way. It does have a strong relationship. But the researchers conducted a survey asking 110 students the number of musical instruments they play and what their math grade is. What is one of the variables? The math grade, right? What's the other variable? Number of instruments played. Good. So if you fill those in, you're on the right track. All right, the researchers found that students who play a greater number of musical instruments tend to have a greater average grade in math. It's more likely that blank causes an increase in blank. So is it that math grade causes an increase in instruments played, or instruments played causes an increase in math grade? Good, that makes more sense because I have tons of students that have great grades and they don't play any instruments. So this is probably the more logical order. Good, it's doubtful that blank causes an increase in blank. Good, it's doubtful that math grade causes an increase in number of instruments played. Even though there is a strong positive or negative correlation, good, because when one increases, so does the other. This does not imply what? Good, it does not imply causation, because there may be other reasons that someone, good, there may be other reasons that someone has a good grade in math. So like, what is some of those reasons? So more studying, more preparedness, maybe they have better circumstances going on in their life. All right, so there's other reasons, so that's why it does not imply causation. Any questions? All right, so we'll have time for the puzzle piece tomorrow. Just make sure you get your missing stuff turned in.